this next session looks at being able to recognise and also to sketch a quartic. A quartic has its highest power of x being 4. So x to the power of 4 is the highest power, the 4th degree. So in general form, this is what our rule looks like. Ax to the power of 4 plus bx cubed plus cx squared plus dx plus e. So that's the general form for a quartic. And if you're looking at the graph there, what you should be able to see is that it looks something like a quadratic, but it has a much flatter base to it. So if you have a look at the base down there, it's much flatter. So you need to be able to, when you're sketching these graphs, differentiate between something that is a x to the power of 2 and x to the power of 4. The other form that we will be looking at is this one here, which again looks like turning point form for a quadratic. But of course the power here is a 4 rather than a 2. But for all intents and purposes, we can read off that stationary point just like we do read off the turning point for a quadratic. So let's have a look at some examples and see how we go with it. Y equals x minus 2 to the power of 4, take away 4. So it's a quartic and it's in that turning point type of form. So straight away, and we'll call it a stationary point rather than a turning point for a quartic. And our stationary point is 2, negative 4. So I'm gathering all the information that I can about this graph. The other thing is that I can tell straight away what the trend of my graph is, because here it's a positive. So it is like that. And remember, it's a flatter base. So I've got my trend. What else do I need to sketch a graph? Well, I need my y-intercept. So y-intercept, I let x equal to 0, and I get y equal to 0 minus 2, so it's minus 2 to the power of 4, take away 4. Now, negative 2 to the power of 4 gives you a positive answer, and it gives you a positive 16, which is 12. So that coordinate is 0, 12. And as per usual, I need to find my x-intercepts. So let's do that. X-intercept, let y equal to 0. And so 0 equals x minus 2 to the power of 4, take away 4, bring the 4 over, 4 equals x minus 2 to the power of 4. And I want now to get rid of that power of 4, so I'm going to take the 4th root of 4, which equals x minus 2, and then I will bring over my 2. Now remember, because I've got a 4th root there, I'll have a plus and a minus. So a plus and minus 4th root of 4 plus 2 is equal to x. So my intercepts are the 4th root of 4 plus 2, 0, and minus the 4th root of 4 plus 2, 0. Now, of course, when I label my graph, I'm going to label them with those exact values. But if you were going to think around about where that value was, the 4th root of 4 plus 2, that's around about 3.41. Well, it's not around about, it's approximately. And this one, negative 4th root of 4 plus 2, is 0.59. So that's around about where you would place them on your graph. So let's start plotting some of those points. We've set up our axes, y and x. And so my turning point or stationary point is at 2, negative 4, which would be around about there. So that's 2, negative 4. My y-intercept is at 0, 12, which is up there. And my x-intercepts, one would be less in the middle of 0 and 1, if you like, which is there. And the other one is at around about 3.41, which is around about there. So now my graph needs to go through. Remember, I need a flat base here. So it goes like that. and I didn't manage to go through that very well, but you can see my graph looks something like that. This one is the 4th root of 4 plus 2 comma 0. This one over here is negative the 4th root of 4 plus 2 comma 0. And that is my quartic. Again, just try to emphasize that flatter base when you are sketching it. All right, we're looking at another one here, which is y equal to x plus 1 to the power of 4 plus 2. So let's again start off doing it exactly the same way by gathering all the information that we can. So I have a stationary point here at -1 and 2. What is the trend of my graph? Well, again, it's a positive, it's upright, so it's going to look like that. All right. Y-intercept, let x equal to 0. Okay, let x equal to 0, and you get y is equal to 1 to the power of 4 plus 2. 1 to any power is 1, so 1 plus 2 is equal to 3. So 0, 3 is your y-intercept. Now, let's think about this particular graph because of the stationary point being at -1, 2, which would be -1 and 2, it's going to be there and it's upright, which means I'm not going to have any x-intercepts. So I'm not even going to go and bother finding them now. So I've got my stationary point, that's 1, that's 2. I know that my y-intercept is at 3, so I've got something that looks like that. Okay, that's y, that's x, -1, 2, because that's our stationary point there. This is the point, 0, 3. And there is our graph of that quartic. These questions are asking us to solve for x. So we've got a quartic, x to the power of 4 minus 8x is equal to 0. As per usual, I will always take out a common factor first, no matter what sort of factorisation I'm doing. So you can see there that we have a common factor of x, and I'm left with x cubed minus 8 inside. All right, and that all equals 0. Now, I can use the null factor law here. I could factorise if I like that x cubed minus 8, but that can easily be solved because you've only got one x there, and I'll show you what I mean. So I'm letting x equal to 0, and I'm letting x cubed minus 8 equal to 0. And again, because I just have the x there, I can bring the 8 over the other side and it becomes positive 8. And then I can do the cubed root of 8. And we know that the cubed root of 8 is equal to 2. So when I solve that, my two x values are 0 and 2. Looking at example B here, x to the power of 4 minus 8x cubed minus 24x squared equals 0. Again, I'm going to look for a common factor first, and my common factor would be x squared. That's the smallest power that I can take out, so x squared, which leaves me with x squared minus 8x minus 24 inside the bracket equal to 0. Now, inspecting that quadratic there, so I've got x squared equal to 0, which means x equal to 0, and I've got x squared minus 8x minus 24 equal to 0. But using cross-bridge method here, I need factors of -24, which add up to -8, and I can't find any. So really, my next step would probably be having to complete the square or use the quadratic formula. It doesn't matter. So if you use the quadratic formula, a equals 1, b is equal to minus 8, c is equal to minus 24, x equals minus b plus or minus the square root of b squared minus 4ac on 2a. So let's substitute in minus 8 is positive 8 plus or minus b squared is 64 minus 4 times a is 4 times c gives you a positive 96 because a negative times a negative is a positive, and then divided by 2a, which is 2. So you get 8 plus or minus the square root of 160 on 2. Now that can be simplified down into, if I take out a common factor there inside the square root sign, I've got 8 plus or minus 4 times 40 on 2. So now I can take out a common factor of 2. So 2 outside of 4 plus or minus square root of 4 was 2. So now it's just root 40 on 2, and they cancel out. So there is my 2x values. So all up, my x values for this one would be x equal to 0 and x equal to 4 plus or minus root 40. So that's a very complex one in terms of the solutions that you get, but you are just really either completing the square or the quadratic formula and tidying it up there. So we are just solving quartics. Sketching these last two graphs, hopefully you notice that they are the same questions from example 17, where we've done a lot of the work for them. So we know for y equal to x to the power of 4 minus 8x that our x-intercepts were 0, 0 and 2, 0. Now the trend of this graph, again you've got a positive there, so the trend would be an upright graph. So y-intercept, there is nothing there, so that is 0, 0. So you're not dealing with a lot of information here. You know 0, 0, and you know 2, 0. So let's make that 2 and 4. So this is going to be 2, 0. So drawing the graph here, we are going to, again, we don't know our stationary point. We haven't got the ability to work that out yet. So we're going to draw something with a pretty flat base there and not looking like a quadratic. Let's have a look at the next one here. Now, the next one, this is quite a complicated one. Not only was it complicated in terms of finding the x-intercepts, which we found in example 17, but in terms of drawing it, because it's in general form. The graph will either look like a W if it is a positive x to the power of 4, or an M if it is a negative x to the power of 4. So this is a positive x to the power of 4. We'll be looking at a graph something like this. So what did we find when we found our x-intercepts? So x-intercept, we found that we got 0, 0, and the other one was 4 plus root 40, comma 0, and 4 minus root 40, comma 0. Again, y-intercept here, we've got nothing there, which means that our y-intercept is at 0, 0. Again, we need to know approximately these values. So 4 plus root 40, well, we know root 36 is 6 and square root of 49 is 7. So somewhere in between there, if I plug it into my calculator, just to get an approximate, that's 10.32. And plug this one in, I get minus 2.32. Now, if that was tech-free, again, you would use that reasoning. Square root of 40 is 6 point something, and therefore 4 minus 6 point something. So we can do these tech-free. It's just where we place the value is just going to be an approximate value. So let's put some of our information in. We've got 0, 0. We've got 10.32. So that's 10.32, 4 plus root 40 would be around about there. I've gone up in 2's on my x-axis. So that's that one, 4 plus root 40, comma 0. And my other one is around about here. And that is 4 minus root 40, comma 0. Now I know I have to go through those 3 x-intercepts. So that one, and that one. And my graph, my trend, has to look kind of like that. So an upward W. So again, I don't know how far down to go because I don't know my stationary points, but I know that I'm going to go through there and up there and come back down again. Okay, and that is what my quartic will look like. I haven't got these values here. All right, I've only used my x-intercept.